we did not have time to finish example 6 from the 6.5 notes about graphing tangent and cotangent. This is a transform cotangent function, and I want to finish it now. But first I'm going to review a bit what we did. The first thing we did was we tried to find the vertical asymptotes. In order to find them, we thought about where the vertical asymptotes were for the parent function. So for the parent function, the vertical asymptotes are at x equals 0 and x equals pi. For this function, and we can think of this as 1/2 cotangent of 1/3 times x. So for this function, we have 1/3 x, or x over 3, instead of x, like in the parent function. So we can set whatever inside the cotangent function, x over 3 equal to 0, set that also equal to pi. When we solve those for x, these are our vertical asymptotes, and this is in the base cycle, right? In one cycle, the one nearest the origin. Okay, and then we went ahead and we found the period. Two ways to think about the period. One is take pi, which is the period of cotangent, divide by b, which is 1/3. So pi divided by 1/3 is 3 pi. Or you can simply look at the distance between the vertical asymptotes. The distance from 0 to 3 pi is 3 pi. The key points, so key points on tangent occur every 1/4 period. So I'm going to squeeze that in here. Key points are every 1/4 period. So in this case, the period times 1/4 is 3 pi over 4. So we're going to have key points every 3 pi over 4. This is going to help us set up our scale on our x-axis. The next thing we did was we transformed the key points on cotangent. These were pi over 4, 1, pi over 2, 0, and 3 pi over 4, -1 from the parent function. And then we said what transformations occur. We're going to multiply x values by 3 because we have x over 3 here. We do the inverse to x, what we see in the function, and y values are multiplied by 1/2. So these are going to be the points that we're going to plot. Okay, so to go ahead and sketch this, let's set up our scale for both the x and the y axes. So I'm going to let 2 squares be 1 unit on the y, so that'll be 1, 2, and we'll do -1. And on the x-axis, I want to make my key points intervals are every 3 pi over 4. So I'm going to let 2 squares be 3 pi over 4. So this is going to be 3 pi over 4. 2 times 3 pi over 4 is 6 pi over 4. I'm going to simplify that to 3 pi over 2. 3 times 3 pi over 4 is 9 pi over 4. So my next spot is going to be 9 pi over 4. And then the next one, 3 pi over 4 times 4 is 3 pi. And then I'll put the same numbers in the negative direction. So -3 pi over 4, -3 pi over 2, -9 pi over 4, and -3 pi. Okay, so now we've got our axes set. And then I'm going to plot my vertical asymptotes. So I'm going to put those at x equals 0 for my first one. One cycle is going to end at x equals 3 pi. And then I can squeeze one more in on my graph. I'll put one in the negative direction at x equals -3 pi. Okay, and then finally, let's put some points on here. So we've got our key points down here for one cycle. I'm going to plot those. So we've got 3 pi over 4, 1/2, 3 pi over 2, 0, and then 9 pi over 4, -1/2. And then we're going to go ahead and put a nice smooth curve connecting these points for one cycle of the cotangent function. And I'm going to copy that over one period to the left. So I'm going to put those points on here. So I'm going to be at -3 pi over 2, 0, -9 pi over 4, 1/2, and -3 pi over 4, -1/2. And then I'll go ahead and sketch that.